Welcome back, everyone. This is Marwan. Great to see you all again on the channel. Today, I have something absolutely mind-blowing to share with you. We're going to build a complete music production studio app in just 20 minutes that would normally cost around $5,000. I want to give you a quick overview of what we'll be doing. I'll be using prompt engineering with Claude 3.7 Sonnet and Tempo Labs to rapidly create a professional-grade music app. This is going to demonstrate how powerful AI-assisted development has become. For this special video, I'm going to pass the mic over to YTB Blogger Voice provided by CapCut AI, who will guide us through the entire build process and explain all the technical details. Take it away, YTB.
What's up, everyone? Today we're going to blow your mind with something that even shocked our producer friends. We're building a complete professional-grade music production studio app in just 20 minutes using Tempo Labs. Now, if you're into music production, you know that professional DAWs like Ableton, Logic, or Pro Tools cost thousands of dollars to develop and take years to build. But what if I told you that with the right tools and approach, you could build something with professional features in just an hour? That's exactly what we're doing today. And when we showed it to our producer friends, their jaws literally dropped. One of them even said this would normally cost around $5,000 to commission from a developer. Before we dive in, make sure to smash that like button and subscribe if you want to see more content about building impressive apps in record time. Let's get started. First, let's look at our initial prompt for the core architecture and UI. This is where we establish the foundation for our entire application. I've carefully structured this prompt to cover the core UI framework with a dark theme and responsive layout, a multi-track sequencer with WebGL-powered waveform rendering, tab-based navigation with state preservation, and technical requirements like Expo SDK version and TypeScript. I'm now copying this directly into Tempo, and we'll see what happens. When I arrive at Tempo, I select Generate an App because we're creating our music production studio from scratch. Tempo then asks what I want to build, and this is where the magic happens. I simply copy and paste our entire prompt 1 that Claude helped us craft. This prompt is packed with technical specifications we're requiring. React Native 0.71 with a Hermes compiler enabled for performance, TypeScript 5.0 with strict typing, and proper component memoization to prevent re-renders during audio playback. These details are crucial because audio applications need to maintain consistent performance. Any frame drops will be immediately noticeable to musicians. Once I paste the prompt, Tempo's AI immediately begins analyzing it to understand what we're trying to build. Behind the scenes, it's parsing our requirements and generating a complete application architecture. It creates a product requirements document PRD, a user flow diagram, and begins scaffolding the actual components we specified. What's incredible is how Tempo interprets our specifications for a dark-themed interface with illuminated interactive elements, the multi-track sequencer with WebGL-powered waveform rendering, and the tab-based navigation system. All these components begin taking shape without me writing a single line of code. As you can see in the left sidebar, Tempo is generating each component in sequence, from the wireframe specification to the routes, sequencer, control panel, and all the specialized audio components we need. It's building everything according to our exact specifications, maintaining the performance requirements we outlined for professional audio processing. In just minutes, we have a development environment up and running with all the necessary dependencies installed and a project structure that perfectly matches what we described in our prompt. This would have taken days or even weeks to set up manually. And remember, this is just our first prompt. We've established the core architecture and UI framework, but we still have 4 more prompts to implement for the audio engine: collaboration features, performance optimizations, and platform integration. Let's see how our app is shaping up so far. Now, let's move on to the second prompt, which focuses on the audio engine and creative tools. This is the heart of any music production app. In this prompt, I've specified a low latency audio pipeline using Web Audio API, WebAssembly accelerated DSP for effects processing, pattern sequencer with variable grid resolution, multi-format export engine, technical details for audio scheduling and memory management. Let's copy this into Tempo and see what happens. This is our project screen where musicians can access all their music projects. After implementing the second prompt, Tempo has built a powerful audio engine behind this intuitive interface. The grid layout shows different musical projects with custom thumbnails and descriptions: summer beats, midnight jazz, urban rhythms, and more. Each card displays when it was created and gives a brief description of the project's style. On the left panel, you can see the technical specifications we requested in our prompt. The multi-format export engine supports WAV MP3 and AAC with different quality settings. We've also implemented stem separation for exporting individual tracks and direct sharing to social platforms. The technical foundation is impressive. Our custom audio scheduler guarantees sample-accurate timing, essential for professional music production. The memory pooling system prevents audio glitches by recycling buffers instead of allocating new ones during playback. Tempo has created the actual audioengine.ts file shown at the bottom, which contains the core processing logic. This isn't just a mock-up, it's functional code that implements all our technical requirements, including web workers for heavy computations, and proper error boundaries around audio processing. What would normally take audio engineers weeks to build, we've created in minutes using prompt engineering, and we're just getting started. Our next prompt will add real-time collaboration features. Here we're looking at the overall application architecture. Tempo is generated for our music production app. The diagram shows how the different views and components connect to each other. Each component is designed to work together while maintaining strict isolation between the UI and audio processing threads. What's particularly impressive is the file list at the bottom left. Tempo has created multiple audio processor files, including audioengine.s, the core audio processing system, gain processor.js for volume control, compressor processor.js for dynamic range compression, Q processor.js for frequency equalization. These aren't just placeholders. They're fully functional audio processing modules that implement the Web Audio API's audio worklet pattern. Each processor handles a specific aspect of the audio pipeline while maintaining the performance characteristics we specified. This architecture diagram demonstrates how Tempo has organized our application to ensure consistent performance across different device capabilities with graceful degradation when necessary. The separation between UI components and audio processing is crucial for maintaining both visual smoothness and audio quality. Looking at the code view, we can see Tempo has generated all the core components for our music production app. The home.tx file shows React imports, along with Framer Motion for animations, and our custom components like app layout and tab navigation. In the File Explorer, there's a comprehensive set of TypeScript files including Collaboration View, Projects View, Control Panel, Sequencer, and Track Controls. The development server is running smoothly, with dependencies optimized in just 403 milliseconds. Now looking at the sequencer implementation, this is where our app truly shines. We have a fully functional multi-track interface with color-coded waveforms, orange for synth, red for drums, and blue for bass. The timeline displays measure numbers from 1 to 16 with a zoom control for detailed editing. The control panel includes master volume and pan controls connected to our gain processor, along with transport controls that interface with our custom audio scheduler. Each track has mute and solo buttons, and the right panel shows track-specific controls for the selected drum track. The dark theme reduces eye strain during long sessions, while the WebGL-powered waveform rendering provides smooth visualization even with complex audio data. What makes this remarkable is how quickly we've gone from a text prompt to a professional-grade interface with actual working code. The sequencer isn't just a pretty UI. It's connected to sophisticated audio processing modules that handle everything from precise timing to spatial audio positioning. All of this would typically require weeks of specialized development, but we've built it in minutes using prompt engineering. Our samples library organizes sounds by category: bass, drums, synth, keys, vocals, and guitar, with visual previews for each sample. You can filter categories and instantly preview any sound before importing it to your project. The sequencer displays color-coded waveforms for each track: red for drums, blue for bass, and orange for synth. Each track has mute and solo buttons for quick adjustments, and the timeline provides measure numbers with zoom control for detailed editing. When browsing samples, the sequencer remains visible below, preserving your work context and creating a seamless workflow between finding sounds and arranging your tracks. The right panel gives you track-specific controls for volume, pan, and effects, all connected to our professional-grade audio processing modules. This integrated approach eliminates the constant context switching found in other music production apps, streamlining your creative process from inspiration to finished track. For our third prompt, we're focusing on backend integration and collaboration features using Supabase. This will transform our app from a standalone tool into a collaborative platform. This prompt specifies a comprehensive database schema with security policies, real-time collaboration with operational transform algorithms, audio asset management with chunked upload-download, offline capabilities with transparent resynchronization, technical implementation details for React Query and WebSockets. Let's copy this into Tempo. Looking at the left side of the screen, we can see Tempo is now implementing our Supabase integration for the real-time collaboration features. There's an npm install command for TanStack React Query, and Supabase is Supabase AS. These are crucial packages for our backend connectivity. We also have two key files being created: circlib supabase client.es, which will establish our connection to the Supabase backend, circlib supabase schema.sql, containing our database schema for users, projects, tracks, patterns, and samples. This shows how Tempo is implementing the backend architecture we specified in our prompt, connecting our music production app to Supabase for real-time collaboration features. The schema.sql file will define our data structure with proper relationships and security policies. We're connecting our app to Supabase to enable real-time collaboration. We've installed TanStack React Query and Supabase AS to handle data fetching and backend connectivity. The key files we are creating include client.ds for the Supabase connection, schema.sql for database structure, hooks.ts for custom data, fetching hooks, and providers.idx to make Supabase available throughout the app. Our collaboration interface features an invitation system with session codes and real-time indicators showing who's editing what. Behind the scenes, we're using an operational transform algorithm to prevent editing conflicts. For offline support, we've implemented background synchronization that lets users work without internet connection, with changes syncing automatically when they reconnect. All this collaboration functionality was generated from our third prompt, turning a text description into a working backend and front-end implementation. Now we're looking at Tempo implementing our Supabase integration from our third prompt. On the left side, Tempo AI is creating several crucial files for real-time collaboration. srglib supabase client.hes sets up our connection to the Supabase backend. srglib supabase schema.sql defines our database structure. srglib supabase hooks.es creates React hooks for data fetching. srglib supabase providers.ex provides context for database access. srglib supabase sync.ts handles synchronization for offline editing. srclib supabase audio processing.cs connects audio data with the backend. Components authforms.tx implements user authentication. Components collaboration collaborati on context. TSX manages real-time editing. In the center, we can see our core application description with highlighted features, including the dark-themed interface, multi-track sequencer, tab-based navigation, and real-time collaboration tools. that allow multiple users to work simultaneously. The preview panels on the right show different views of our application, the sequencer with audio waveforms, the project screen with our music cards, and a collaboration interface showing how users will work together. This implementation is creating the foundation for our multi-user collaboration system using operational transform algorithms to prevent conflicts during simultaneous editing with visual indicators, showing who's editing what part of the project. This error screen perfectly demonstrates why we incorporated extensive error handling in our music production app. Tempo has detected a syntax error where our hooks.ts file is missing the use delete sample export that our samples view component needs. What's impressive is how Tempo handles this error situation. Rather than crashing the entire application, it clearly identifies the exact issue with detailed error information, contains the failure to just the samples module through error boundaries, allows the application to continue running even without Supabase credentials, offers an AI-powered fix without requiring manual code intervention. Tempo's fix with AI feature is particularly powerful. It can analyze the error context and automatically generate the missing hook with the correct implementation. This showcases the platform's built-in error resilience. For our demonstration, instead of using up one of our limited prompt counts with Tempo, we'll copy this error into Cloud and integrate it with our fourth prompt. This approach lets us address both the error handling and performance optimization aspects simultaneously. The error we're seeing is exactly the type of issue our performance optimization and error resilience prompt was designed to handle. Our fourth prompt focuses on performance optimization and error handling, critical aspects that separate professional grade apps from amateur efforts. This prompt covers audio thread isolation and performance profiling, virtualized track rendering and adaptive resolution, autosave system with corruption detection, battery and thermal management, technical implementation for monitoring and telemetry. Let's copy this into Tempo. Our fifth and final prompt is designed to address package dependencies, prepare for launch. This is where we'll try to fix more of the error we encountered with just one prompt remaining on the trial version. This prompt includes comprehensive package management strategy, cross-platform optimization for iOS and Android, deployment pipeline configuration, monetization and growth features, technical requirements for integration with services like RevenueCat. Let's copy this into Tempo and see if it resolves our issue. Unfortunately, we're still seeing some dependency errors. The package management system is correctly identifying the missing dependencies, but there seems to be an issue with installing them in the Tempo environment. This highlights an important reality of development, even with advanced AI tools. You'll still encounter challenges that require troubleshooting. While we didn't get the app fully functional, we got remarkably far with just 5 prompts. Despite not resolving all the dependency issues, which is honestly my own fault, let's look at what we accomplished. We built a sophisticated music production app UI with custom controls. We implemented a professional-grade audio engine with effects processing. We created a real-time collaboration system with version control. We added comprehensive performance optimizations and error handling. We established a package management and deployment strategy. Now let's see what my producer friends thought when I showed them how far we got with just 5 prompts. Wait, you built all this by just writing prompts? That's insane. This would take a normal development team weeks to put together. The multi-track editing interface looks smoother than some professional DAWs I've used, and the collaboration features are actually better thought out than what I'm currently using. If someone asked me to estimate what this would cost to build traditionally, I'd say at least $5,000. And that would be rushing it. The fact that you got this far with just prompts is mind-blowing. The benefits we've showcased in this experiment are transformative, dramatically reduced development time from weeks to minutes, the ability to implement complex features without specialized knowledge, a modular development approach that's easy to extend, professional-grade architecture following best practices, a pathway to building sophisticated apps, even if you're not a professional developer. While we didn't get everything working perfectly, this demonstration shows just how powerful prompt engineering can be for application development. The future of development might not be about writing every line of code manually, but rather about effectively communicating your requirements to AI systems that can generate functional code. If you found this valuable, smash that like button and subscribe for more content on AI-assisted development. Let me know in the comments what type of app you'd like to see me build next using this prompt-driven approach. Thanks for watching, and I'll see you in the next video.